All right, so we're going to make a foldable today. And so you're going to start with your piece of paper, and you want to fold it lengthwise in half, but not quite in half. You want to leave like maybe a finger width from this edge to that edge. Okay. Then we're going to fold it in half completely the other direction. So we're going to take the bottom and we're going to go all the way up to the top. Crease that real good. And then one more time, bottom all the way up to the top. So we're creating 4 tabs there. Then when you unfold, we're going to take the short half and we're going to cut along each of these folds to create 4 different flaps. All right, so one of the tricks with the gas laws unit is figuring out when to use each different equation. How do I know which equation to use? Because we've talked about a few. Okay, we talked about the combined gas law, which is actually a combination of Boyle's law, Charles's law, Avogadro's law, and Gay-Lussac's law. We talked about Dalton's law of partial pressures. We talked about using Dalton's law of partial pressures to look at things that are being collected over water. And then we also talked about the ideal gas law. So lots of different laws in here. And the question is, when do I use each one? So let's start with the combined gas law. Okay, the combined gas law is a before and after. So we're going to put the variables we would see here. So this is where you're going to have a P1 and a P2, or a V1 and a V2, or a N1 and an N2, or a T1 and a T2. So remember, with the combined gas law, if there are variables we end up not having or not needing, we can just take them out of the equation. So let's rewrite that combined gas law in here. That one is P1 V1 over N1 T1 equals P2 V2 over N2 T2. All right, and you can remove any variables you don't have. So if I don't have N values, I can take N out. If I don't have T values, I can take T out. And then, oh look, there's Boyle's law. Okay? If I don't have N or P, I can take those out, and then I have Charles's law. Okay? If I don't have P or T, I can take those out, and then we have Avogadro's law. So the combined gas law is kind of all of those laws put together. A couple of things you need to remember with the combined gas law is that your P and V can be any unit as long as they match. In other words, if you have pressure in atmospheres on one side, it has to be in atmospheres on the other side. Okay? If you have volume in liters on one side, it has to be in liters on the other side. All right? N has to be in moles. That's always true. N always has to be in moles. T always has to be in Kelvin. Okay? So those two things are always true no matter what law you're using. N has to be moles. T has to be Kelvin. But in this case, your pressure and volume can be any unit that you want as long as they match one another. So that's our combined gas law. So then the next one we talked about was Dalton's law of partial pressures. And this is where we have a mixture of gases. And since this is about pressure, all of your values are going to be pressure. So you're going to have a total pressure, you're going to have a pressure of gas A, you're going to have a pressure of gas B, you're going to have a pressure of gas C. However many gases are in your mixture is what that is going to be. Okay? But the key here is that for Dalton's law of partial pressures, it's all pressure values. Everything that you're given is pressure. So our total pressure is equal to the pressure of our first gas plus the pressure of our second gas plus the pressure of our third gas. However many gases we have, we add them together, and that gives us our total pressure. And here, our pressure can be in any units, but all of them must match. So we could do this in atmospheres, we could do this in torr, we could do this in millimeters of mercury. It doesn't matter which one we use, as long as total is in the same as 1, 2, and 3. So if this is atmospheres, this has to be atmospheres, this has to be atmospheres, this has to be atmospheres. They all have to be the same. Now, an application of Dalton's law of partial pressures that we talked about was when we collect things for over water. So we have the phrase collected over water. This is an application of Dalton's law. Okay, so what are we going to see here? You're going to see the phrase collected over water. You're going to have a temperature value, and you're going to have a total pressure value. Okay? And you are typically going to be asked for the pressure of the dry gas. All right, so this one is really similar to this one, where most of the stuff that we're being given is pressure values, except for they give us one temperature, and they tell us that this was collected over water. Okay, so when we have a collected over water problem, the pressure of our dry gas is going to be equal to the total pressure of the system minus the pressure of the water. And that is going to be something that we have to look up on our chart. So if you remember, we had that big chart where we had temperature values in one column and then pressure values in the next column. So over here, the first thing we would do is look up the pressure of the water at the given temperature. Okay, so we would get that big chart, which you'll have a copy of that for the test, so don't stress over that. You're going to get that big chart out, and you're going to look up the pressure of water at that given temp. And then number 2, we need to make sure the total pressure is in millimeters of mercury, because that chart that we have the pressure of water on, the pressure of water is going to be in millimeters of mercury. Okay, so we need to make our total pressure match the pressure of the water off the chart. Okay, the last law that we talked about was the ideal gas law, and remember, this is actually derived from the combined gas law, which actually makes this really tricky because kids really struggle sometimes to figure out, is this combined or is this ideal? So over here, you're going to have a single pressure, a single temperature, a single volume, and a single number of moles. All right, there's only one of each. Okay, so what's the difference? Up here with combined gas law, we had a before and after, before and after, before and after, before and after. So there's 2 of each up here. Down here is where we have only 1 of each. So our ideal gas law was PV is equal to nRT. Remember that R is the ideal gas constant, and it has a value of 0.0821 liters atmospheres per mole Kelvin. Both of these things are on your formula chart. You don't have to memorize them, you just have to know when to use them. Okay? Some key things with the ideal gas law. Pressure must be in atmospheres in this case because it has to cancel with the atmospheres in the R value. Same idea with volume. Volume has to be in liters because it needs to cancel with the liters in the ideal gas constant. And as always, N should be in moles and T should be in Kelvin. Okay, so I hope that helps as you're practicing in preparation for the test. This is just kind of a way to be like, okay, which gas law should I use? And look at which variables you're given in the problem. So always make the list of variables and then compare it to this here, and that'll help you choose which gas law to use.